Now if the line is parallel to VP, if the line is parallel to VP, its plan will be parallel to XY, and elevation will show us the true length and true angle. If line is parallel to HP, its elevation will be parallel to XY, and plan will show us the true length as well as true angle with VP. Distance from HP is seen in elevation or plan? Elevation. Distance from VP? Plan. In first quadrant, elevation is above XY, and plan below XY. In second quadrant, elevation is above and plan is also above. In fourth quadrant, both plan and elevation are below XY. In third quadrant, elevation is below XY, plan is above XY. If one point of the line is in VP, if one point of the line is in VP, then line will be going from either first quadrant to second quadrant or third to fourth. If the elevation, one point of the elevation is on XY, then line will be cutting HP, and it will be going from first to fourth or second to fourth, right? Okay. Right on. Lines inclined to both the reference planes. Lines inclined to both the reference planes. So see it first. So I have initially a line which is parallel to HP as well as VP. That was our very first consideration. So this is line AB. This will be its elevation, which is parallel to XY, and plan parallel to XY, and we have that particular line appearing in true length in both elevation and in plan. Both are parallel to XY. Also remember that when one view of the line is parallel to XY, other view will give us true length and true angle. Okay. Here both the views are parallel to XY, so both the views are giving us true length and true angle with the planes, which happens to be 0. Parallel means. Now if I rotate this line by angle theta, keeping it parallel to VP, so I have rotated it by angle theta. Rotation in one view is going to be movement parallel to XY in other, and this will straight away come down here, which will again cross check. So this is point B1, B1, B1 dash. This will be B dash. This is how the elevation will be. This will be point B. So rotation in one view. Suppose this view is rotated by angle theta. Becomes point B dash. Then in the other view, the point will move parallel to XY and it has to lie on this projector. So this becomes point B. This will be angle theta. And initially it was B1. These type of problems we have done yesterday. Now see, as the line makes theta with HP, true length is known to us, and one point is also known to us. Now with this, what happens is height of point B from HP gets fixed, because this height is fixed, point A is fixed, theta is fixed, true length is fixed, so obviously this height will be fixed. Okay, so this results in height of other point from HP is fixed. This will also result in plan length fixed. This is the plan length of the line. Now I want to rotate this line so that it will make an angle of phi with VP. Now see the problem. Yesterday it was easier because this line is to remain parallel to HP and should make angle phi with VP. So that angle was clearly visible in the top view, and elevation was parallel to XY. The figure was exactly opposite to this. Now if I am to rotate this particular line AB after rotating by theta so that it should make an angle phi with VP, now it is angle 0 with VP. If I am to rotate, I cannot let this point B come down, because it has to make theta with HP, the line. So it should not come down, and I should rotate it like this. It was initially horizontal. I have rotated it by angle theta, and now I should rotate it by phi. Now this angle phi will not be visible in the top view, because it is not the angle with horizontal. It is not seen in plan. It is not the true length. So it is as if, just say if you can imagine it, I am trying to fix up this particular triangle, because theta should not change, height of B should not change, and this triangle I am going to rotate about this capital A small a, because even A can't move, B cannot come down, true length cannot change, but angle should be phi. So if I rotate it in this direction, now it becomes a tough task for us to understand what is going on. So this is rotated, but this angle won't be phi, because it is not the true length. That angle will be somewhere in this plane, inclined plane. Over here the angle will be phi, not with the horizontal. It cannot be seen in HP. So the line is rotated and it takes position somewhere over here. So this becomes my B2. So this is ultimately B2 and B2 dash, and this becomes my point B. Now what is happening? It is rotation in the plan. So point B dash will move parallel to XY. As I start rotating it, this particular triangle, when it rotates, if that triangle is there, if I rotate that triangle, then at one time that you will be looking along the triangle when the angle is 90 degrees. So point B might reach this point if it is rotated by some angle. Are you getting this? Right now it is the rotation which is seen in plan, and it stops here. Now B point will move. It will be moving parallel to XY and will stop, and here I will get the elevation length. And again, if I drop the projector, it has to pass through the, though both elevation and plan should lie on the same projector, but this angle is not going to be phi, it will be something else. What I have done right now is, first I have rotated by theta and then by phi. one can always do it other way around. First rotate by phi and then lift it by theta. And with angle with phi. So I solved one problem keeping it parallel to VP. I can solve the same problem phi with VP. I will get distance of other point from VP, and it will also fix up the elevation length. It was just a problem similar to this we will have to solve when I mark an angle of phi here, rotate it by phi with VP, keeping it parallel to HP. Rotation in one view is movement parallel to XY in other. This point will move. So I have rotated it by phi. This is still the true length. This is the true length right now. And then go up, and I will get B2 dash. Rather, this was B1. This is B2 dash B2. This will be my B3 and B3 dash. Now what has happened? Here I had got the height of point B, that is path of B dash. Here I will get path of B. I am doing both the constructions on the same problem. Theta with HP 1. Yesterday it was a different problem, phi with VP. Now I have solved it over that only. Right? Actually, you will find that these are solved in this way. Initially it is parallel. It makes theta with HP. One problem is done. Then again the second part. It is making phi with VP. These are our yesterday's problems. So this is AB, A dash, B dash. This angle is phi. This angle is theta, A dash, B dash, and AB. Two different problems. I have solved both these problems one over the other. Here also I have got height of point B from HP, distance of point B from VP. I had got plan length over here, and I have got elevation length over here. Right? Where is the elevation length over here? Elevation length we got it as A dash B3 dash. B3 dash. Where is the plan length? Plan length is A B2. Point A is fixed. Point B, its distance from HP we have calculated graphically. It is this much. Its distance from VP is here. It must lie, A B dash should be here and B should be here. But where exactly on this line? Now I also know that A dash B3 dash is nothing but in reality A dash B dash, because it is the elevation length, and AB2 is nothing but AB. So what I should do is I should take this elevation length and again rotate to get point B dash. And I should take plan length and rotate to get point B. And you can cross check that they will lie on the same projector. And this becomes the final projection of the line. And what we have over here, we will get that. We will always have this thing, elevation length is less than the true length. Do you agree? This is the elevation length, and its true length is here. We know that the shortest distance is this, so true length will be greater than elevation length. plan length is always less than true length. Same thing over here. Now apparent angle, angle made by the elevation, angle by elevation, rather I would say elevation and xy is denoted as alpha, and angle between plan and xy is denoted as beta. These are called as apparent angles. What are true angles? Theta and phi, angle made by the line with HP and VP. Alpha and beta are angles made by the elevation and plan with xy. We will also find that alpha is always greater than theta. Angle made by the elevation is greater, and angle made by the plan is greater than phi. And none of the elevation or plan is parallel to xy. So we cannot see true length anywhere. We cannot see the true angles. What we can easily see is the distances of the points from HP and VP. That's it. Got this? So these are yesterday's two problems, angle with HP and angle with VP, now to be solved simultaneously. Angle with HP will give us two things, plan length and height of the point from HP. Angle with VP will give us two things, distance of the point from VP and elevation length. And then we will have to, so 1, 2, 3, third stage mein you will have to take this distance and mark it from A dash on path of B dash, and take plan length and mark it from A on path of B. So if we are to solve it in 3 steps, this was our first step, this is second step, we again go ahead, we just draw, mark point A dash and point B, point A, sorry. Now take this particular elevation length and from A dash cut it on path of B dash. So take this elevation length and cut it here. You will get B dash, join it. Take this plan length and from A cut on path of B. And if you join them, they will be on the same projector. So what I am going to get is from here this path of B, from here path of B dash, I got elevation length from here and marked, I got plan length from here and marked, and these are the 3 stages of the problem which we are drawing in the overlapped manner. So we should be seeing only one thing at a time what we are doing. Got it? So these many things we will always require. 1. You can solve problem in 3 stages, you can solve it in 1 stage, one over the other, whichever is easier for you to understand. These are the 2 important things. When one point and true length is known, theta with HP we got this, phi with VP we got this. This is stage 1, stage 2, and using these 2, plan length, elevation length and point A dash, I got point B dash. And your check is whether they lie on the same projector. If by chance that angle changes, projector has to be perpendicular to XY. If you don't get them on the same projector, there is some error. So I will retain this on the board. I want you to take down 1 point, second point, this thing, this thing. Our naming is always B1, B1 dash are parallel to HP and VP is our notation that I have used. So A dash B1 dash and A B1, these are both true lengths and line is parallel to HP and VP. In the second case I have got B2 and B2 dash, line is parallel to VP and theta with HP, and B3 was line parallel to HP and phi with VP. That is the nomenclature I am following. So initially 1 1, theta it is 2 2, phi it is 3 3, and finally A dash B dash and AB. Okay. So this angle which we see over here is beta. We cannot see phi. Phi will be visible if you extend this, and in over here it is phi. I am extending the true length and the elevation length, and where they extend and cut is phi. It's difficult to draw this figure, don't go for it. Okay, note the important points, and I will give you one problem to solve. It is line AB, length of line AB is 90 millimeters, point A is 30 above HP and 20 in front of VP. Line makes 45 degrees with HP and 30 degrees with VP. Draw projections. So you have the angles also with you. Okay. First I want you to draw in 3 stages on 1 XY, first part, second part, third part. 90 length will be a bit more. I will reduce the length 60, because if on one side you will have to draw it, it is 60, 60, 60. You will at least require 180. Right. So this will be initially 60, 60, and then the third stage. Draw XY line exactly at the center of the page and solve these 3. And if there is a space afterwards, another 60, which should be there. With your length, it's more than 30. Yeah. So solve first, second, third, and at the end all the 3 overlapped. Ekas page varti kara. Draw this, and again the same thing, but in the overlap manner. Right. Tithas basil te. So we have a problem given as length AB as 60, point A 30 above HP and 20 in front of VP. Theta equal to 45 degrees, phi equal to 30 degrees. Now I am going to solve this problem with the numbering as the sequence in which I have solved it. So it is point A has been marked, A dash and A. Then we take 60 millimeters and mark B1 dash and B1. So my first step is point A. My second step is to mark this 60. Is step 2. Third step is to mark B1 dash. Then I draw a line at 45 degrees is my step number 4, onto which I am to mark the true length, that is 60. Then you rotate this, is my step number 5. To get path of B dash is step number 6, and to get it down is step number 7. To mark, say this is B2 dash and this is B2. To mark plan length is step number 8. So I started initially with line parallel to XY. I have rotated it by 45 degrees. First mark the angle, then I have cut the arc that is 5. I have got path of B dash, step 6. Step 7, I came down, I got plan length. Then marking 30 degrees is step number 9, and rotating the plan is step number 10, rotating the true length, and get the height of path of B. Is step 11. Mark this as point B3. Go up is step 12, and mark B3 dash as elevation length, step number 13. And then you take the elevation length and rotate. So elevation length is rotated is step 14 to get point B dash, step 15, and rotate plan length is step 16 to get point B, and plan length step 17, and finally to check whether they lie on the same projector or not is step number 18. Job is done. From A B3 dash to path of B dash. Path of B dash, yes. So for you I will even mark what I am doing. It is step 1. Mark A and A dash. Step number 2. And 3. Line parallel to XY, get A dash, B1 dash and AB equal to true length is step number 2 and 3. Step number 4, mark theta at A dash. Step number 5, rotate true length equal to A dash B1 dash by theta. That is step number 5. Step number 6, get path of B dash. Step number 6, and mark B2 dash. Step number 7, draw projector through B2 dash. That is step number 7. Step number 8, get plan length parallel to XY, which is A B2. Step number 9, mark phi at A. Step number 10. Rotate true length equal to A B1 by phi. Step number 11. Get path of B and mark B3. Step number 12. Draw projector through B3. Step number 13. Get elevation length parallel to XY equal to A dash B3 dash. Step number 14. Rotate A dash B3 dash till path of B dash and get B dash. Join A dash B dash. Step number 15. Step number 15 is join A dash B dash. Step number 16. Rotate AB2 till path of B and get B. Step 17. Join AB. Step 18. Check BB dash projector. Everyone through? Only the final projection should be dark. Numbering is not required. Angles should be shown, true angles. Now measure alpha and tell me what is alpha. Angle made by A dash B dash with XY. Measure it if you have completed the problem. Angle made by A dash B dash with XY. 57 degrees. Any other answer? 56 degrees. 55 degrees. And what is beta? It is 56, 57, 55. Now corresponding beta values. 57 corresponding is 46 degrees. 56 degrees जिनका है उनका angle beta is this, made by AB with XY. 45, 46. So check your accuracy. There is a unique answer. It should not vary from person to person. Not even a single degree error will be allowed. So you will have to check every mm correctly. Even if you have messed with this 30 to 31 or 29, anything may go wrong. True length, there could be a problem. One of these lines is not parallel, there will be a problem. Don't do that. 46. And then the dimensions which are necessary. Once we are done with this, for this particular problem, what dimension should be shown, which you are required to show? Of course, you will have to show this distance 30. you will have to show 20.
Sir, is it compulsory to show
It is compulsory. Then
left hand side? To see side la आपको
where the point is here, why will you show it here?
that's the distance.
For this is adjustment purpose, it is okay, but otherwise always leave space for the dimensioning. Then for true length, either you can show it here itself 60, and data you should write it in this manner. It is A dash 30 above and A 20 below. 20 below. True length is equal to 60. Theta is equal to 45 degrees. Phi equal to 30 degrees. Out of the entire thing, path of B dash and path of B are the two things which you need to write. You will have to write them. And then answer may you will say it is alpha equal to 56 degrees, beta equal to 46 degrees. This is how the problem should look like. Of course, without numbering. Naming would be useful, but not these numberings, not even those arrows. Now take 2-3 more problems and let us see. Line PQ has P in HP and 30 in front of VP. Line makes 35 degrees with both HP and VP. Line makes 35 degrees with both HP and VP. Draw projections. If true length is equal to 100 millimeters and number 1 point Q is in first quadrant, number 2 point Q is in second quadrant. One small change, if you have not started with it, make this 20 mm. हाँ 20 करा, 30 नको.